Hey there, my name is Alejandro and welcome back for day 59 of me doing the Daily LeetCode challenge until we reach 1 year's worth of green contributions here on GitHub. So today's problem is for September 13th, 2024, and let's get straight into it. Okay, today we get a LeetCode medium problem 1310, XOR queries of a subarray. You are given an array R of positive integers, sure. You are also given the array queries where queries of I equals left of I, right of I, whatever, okay. Sorry. Oh, these are separate arrays. Okay, so we're given R and queries. Okay, cool. For each query I, compute the XOR of elements. Wait, okay. For each query I, compute the XOR of elements from left I to right I. That is R left I, XOR R left I plus 1, XOR, okay. Return an answer where answer I is the answer to the ith query. Okay. Okay, that makes sense. We can take a look at an example. Honestly, the example might be a bit more complicated to look at. Oh, yeah, okay. Okay, this is just a do something kind of question, right? It's not like a minimization or optimization problem where it's like you have to think hard about how you're going to do things. This is a here you go, here's what I want you to do kind of LeetCode problem. So we can just do that, right? Let's just literally take what it wants. So it wants an answer array. So let's do an answer array. This is going to be equal to also a list. And it's going to have ith query. Okay, so this is going to be times length of queries. And for now, we'll just set everything to -1. For I in range length queries, we can even make this an empty array and just do appends every time. I will call this res, you know what, it's fine. Or answer is fine, but okay. For I in range length queries, okay, so we want to do some cool stuff. For each query I, compute the XOR of elements from left I to right I, right? Okay, so we can just get R, so left comma right is equal to queries of I. And we're going to say, for, you know what, for query in queries, this is equal to this. For I in range from left, right? So queries is 0, 1. Okay, to inclusive, right? So all the way up to right plus 1. So right inclusive. We're going to do the XOR, right? So we'll do a plus 1 here. And we'll say bit is equal to R of left. Oh wait, these aren't zeros or ones necessarily. Okay, they're numbers, but okay, that's still something we can XOR. XOR. Okay. XOR equals XOR XORed with queries of I. Okay, then we can do res that append that XOR value, and then return res. So what if we return something like this? No. Left, right equals query, sorry. Okay. Right. R of I. We want R of I. Okay, let's submit this. Too slow? Okay, so that makes this case interesting. Okay, so let's think about things. Okay, so we're gonna have to solve this problem efficiently somehow. Okay, that's cool. So my idea was very simple in the sense that it's like, all right, they tell you to do something, let's just do something and see if the solution works and so on, and let's try to compare ourselves to other people's solutions before we do something more efficient. So my solution right now is very, very simple. Okay, I gotta think about XOR properties, right? So it's like, if I XOR the entire array, right. Maybe I could sort queries. Right, because let's say that queries are indices. Let's say how do you unXOR a bit? If I XOR something with itself, it unXORs itself, right? Or it's like or no, it's A XOR A will give you 0. Okay, I gotta think about this. So if I have, so my idea that I'm thinking of right now is, let's say we have 0 to 3 is the first one, and then the next one is like 1 to 5, right? So all we'd essentially need to do is like we have the XOR of 0 to 3, right? So we just need to XOR this with 4 and 5. And if I XOR it with 0 again, if I XOR it with 0 again, then I essentially get as if though I did nothing. But then it's like if I XOR the full thing with 0, right? Which maybe doesn't get me what I want. No, it just makes itself go away. It's like in cryptographic keys, right? If you have a plain text and you XOR it with a key, and you XOR it with the key again, then what you get is the plain text. So you essentially get the rest of the message. So maybe we could sort queries, and let's look at the constraints first of all, because that can also be very useful. Okay, so this is what I mean. Queries.length is 3 times 10 to the 4. This is definitely something that's n log n-able. The values, yeah, that doesn't matter too much. Okay, 10 to the 4. So the thing you have to keep in mind is usually you can do roughly 1 million computations, right? And so n log n, usually you can get away with even 10 to the 5. Here you're like 3 times 10 to the 4. So you can definitely get away with n log n with queries. So we could do sorting, but I want to do, if I do queries.sort, print queries, and print sorted queries. Maybe I can, oh, whoops, sure. Okay, sorry, I'm just thinking to myself here. What's going on? Oh, okay, this is not commented out. Okay. Sure. Oh, did I use that test case? Return an empty array for now. Okay. So yeah, I get them 0, 0. So okay, so that's actually very cool. So like we could do some sliding window technique kind of thing, which would be very, very cool. So like here in this case, okay, this is actually kind of huge. We'll do up to 10. Do up to 10. Although I saw a bunch of 0 to 298. Okay, so this is also the problem, right? Where it's like, if I have a result before, I should cache it for sure. So okay, so one way we can improve from our solution from before is by caching stuff. Because obviously in the example, it's like we're XORing the values from 0 to 29898 like a million times when we absolutely don't have to, right? So like one thing we could very much do is we could have a cache. Cache is equal to this. It's like self.memo. If left comma right in cache reset append cache of get this tuple and continue. Otherwise, we're going to say cache of left comma right is equal to XOR. So now I think I might be able to pass this case, but I probably won't be able to pass. Oh yeah, I return empty array here. Okay. Yep. Okay, so I definitely passed that one much more quicker, but again, it doesn't mean I will pass the last test case. It's definitely a great improvement, but yeah, okay, this is exactly what I mean. It's like, oh, okay, sweet, I saw that. But again, you see, like, okay, I'm at 5% and so on. I'm obviously going to be much, much slower than other people, right? 6202 milliseconds. Essentially what I'm doing here is like whenever I've computed, like whenever I've XORed from left to right before, I essentially say like, oh, hey, I don't need to recompute that thing anymore, right? But the only problem is, again, like everything might be like shifted by one and so on, so you end up doing like a lot of different work and so on, which again, this is probably why I'm at 5%, and I think it's much more. So if I sort queries, queries dot sort, I'm not much slower, right? I probably will still be at, let's see. I mean, I will be slower, but what? How the heck is that possible? Oh, do I not get them in order? Oh, okay. Oh, that's annoying. So you can't sort queries? Right, so you get the queries in order and they want the result in that order. But you could also, you could also put these all in a dictionary, right? So, right, so a query could be mapped to a value. And at the end, it's like for querying queries, like return d of query for query and queries, right? And then it's like sorted queries. Oh. Okay, so this means I just got a result. D of query is going to be D of left comma right is going to be equal to, actually I can just do cache of this as a tuple, can't I? Right, and if I use this test case, do I pass it? Wait, what? Why can't I use the test case? Okay. Otherwise I can submit and see. Okay, so that works. But yeah, you see like 6218, I'm like, I'm not even slow. I'm barely slower. So okay, so we can do something like that. So okay, good. Good to know that the queries need to be in order, so that's one thing. Okay, so we can return cache of tuple query for querying queries. So that way we preserve the order, right? So we have access to a sorted queries here, but we don't forget the order of the original queries. And then it's like for each query, we're gonna compute the value it should have inside our cache here, and at the very end return like each of those computed values for every query in the query's order, right? Because if we don't do it in order, what you'll see is that the order matters, and so they need to be able to do make sure that that's the thing. Yeah, so if I do something like backwards, we'll get an incorrect solution. Yep. And there we go. But if I don't do it out of order, then we get a correct solution. But okay. Okay, very cool. So my idea is this, right? We want to make this more efficient. We're obviously at 5%, so I think that if they put some ugly test cases, our solution would be time limit exceeded. I'm actually surprised that our solution kind of passes. So I mean, whenever you can, if you can throw a cache at the problem, always throw a cache at the problem, or like memorize the problem and so on. Like, that's what dynamic programming is. It's just brute force, but with cache, okay. So my idea is essentially this, where it's like if I XOR, if I sort the queries, right? I'll have something like maybe 0, 4, then like 0, 5, 0, 6, and obviously like there's a lot of repeated work, right? If I have to XOR every value between like 0 to 4, and then next time I have to like XOR all the values between 0 to 5, well, it's essentially just this XORed with the very last element, and then this is the same thing as XOR with the very last element of 6 and so on. And even if I have another one, right, which is like 1 to I have to be careful. If I do like 1, 3, then essentially okay. Maybe at some point I can like, do some work every single time. I'm trying to think about the most efficient way to do this, right? For query I, because like this is obviously like very suspicious just by nature of XOR, right? Whereas like if I XOR with r left I again, it's as if though I never XOR with that, so I can kill that, right? Whereas like here if I XOR with the 0th element, I essentially have, so like 1, 3 is essentially equal to 0 XOR with 0 to 3, right? So I can just XOR with 0 in order to get that value. But then it's like I don't have 0 to 3, right? Okay. So we can essentially we can cook. No worries. This is good. Left right equals query. So here, if we've already seen our cache, we continue, right? We're just gonna keep this cache idea. Now we're in sorted queries. Last num seen. What are queries values? Queries that like, oh, they're indices, right? So last num seen was -1. If last prev left, if prev left is less than left, then we're gonna take the time to do some new work, right? The only problem is okay, I'm trying to think, because it's like it's not as easy. Whereas like if I have something like like 1, 6, this is very easy, right? It's just this XORed with the 0. But if I have something like 1, 3 where I didn't have 3 but there before, maybe I just have to recompute the work. But then it's like that defeats the whole point, where it's like I want to make things efficient. It's like maybe it's just like it is efficient whenever you can do something clever, and then if you can't, you just can't, right? If prev left is less than left, okay, I'm trying to think about how to do this. This is an interesting problem. I don't work with bit manipulation problems all the time. Yeah. This is cool. I do believe there is merit in sorting, but like maybe I sort also based on the... Maybe I sort based on the right values instead of the left values. Ooh, if I sort based on the right values... very interesting. If I sort based on the right values, I could also XOR the full thing once. What if I XOR the full thing once? If I XOR the full thing once, but then it's like it doesn't matter, right? Like if I have a tiny subset of the array, it's more efficient to XOR the elements in there than it is to like unXOR all the other elements from before. Ooh, maybe maybe I XOR everything once. Oh no. Just how am I gonna do this more efficiently? I'm trying to think. I do believe there is value in sorting the queries. I do believe that is valuable and not useless. But maybe I'm sorting them in the wrong way. I want to know, so because, okay, clearly I'm at 5%, so I'm doing something super inefficient. Right, okay, these guys are in the 300 milliseconds while I'm at the 6,000, so it's like, it's not even close. And I gotta use properties of XOR here. It's like, this is not random. I mean, I can try some ideas for now. Prev left is less than left. Prev essentially I have prev left, so left comma right equals, let's say this is the 1-3 case, prev left equals 0. I want essentially 0 comma x XOR with 0 Alright, so essentially if 1 comma if 0 comma x, okay, this, let's say this is 1 comma x in cache, we're done. Okay. And what's in my, I should also, let's print this cache. Alright, so I have left, right indices and the numbers they correspond to. Okay, cool. Sorry, it's just, I'm thinking like hard. Okay. Prev left is less than left. I need to write this down like as an example so that I don't confuse myself. Right, so left, right, let's say it's equal to 1 and some index x. And our previous left was a 0. We want 1 over 1 comma x, which is equal to 0 to x with an XOR equals cache of 0 comma x, right? XORed with array of prev left. Isn't that what it is? 1 over x. Yeah, so this is the XOR of the elements from 0 to x. This is the element at 0. Right, okay, so if prev left comma right in cache XOR is equal to cache of prev left comma right XORed with the value at prev left. Cache of left comma right is equal to XOR, and continue from then on. Okay, and then something like this works. Okay, it does work. And if I get rid of the prints, okay. Okay, so let's submit something like this and see if we're faster. Ooh, wait. Prev left. Also, we might be jumping by more than one, right? Okay. Okay, I don't want to do a check. I want to do a sweep, right? It's like if I go from 0 to 4 to 1 to 5, I want to make sure that I XOR again with a 0. Essentially, like, I want to be able to find the closest point to me, like, in the dictionary, but the fact that it's 2D is just very annoying. Like, how do I know the closest result to go from? How are people doing this? Are there hints in this problem? There are hints. Okay. I really want to know how to do this efficiently. How can we do this efficiently? Like, I have an idea of sweeping. Maybe I'm focused on the wrong thing, though. So it's like, how do you get from 0, 4 all the way to 1 to 7, 2 to 7, let's say. The point is that you XOR with the 0 and 1. Ooh, you know what you can do? You know what we can do? Ooh, as you sweep. Okay. As you XOR stuff, right? As you XOR stuff, don't just add cache left of right to XOR. Add all the indices up to it that you find. Although you might blow up the memory if you do that. But again, we're getting like okay. We used to be getting like crazy good on memory. If I remove this and I resubmit, okay, that's one thing we definitely miss. Okay, it says 10%. I don't know what we're doing, but before I was saying we were doing rock solid on memory. But okay, I just got an idea. So here we're going to say cache of left all the way up to index I is going to be equal to XOR. And we don't even need to do this. Whoops. This includes right. What? Memory limit exceeded. You can't just cache everything in the universe. Yeah, okay. So too much memory. People have got to be doing this in a cool way. Maybe here I can do cache dot clear. Oh no, I need the results. Oh my goodness. Maybe I keep a D here of my solution. Okay. Does that help me manage memory better? It's like, well, I'm still on the same left. I might as well grab everything I can. Right? Oh, also, I'm just going to be doing repeated work as well. It's like, if that one is not exactly in the cache, then I'm going to do a bunch of repeated work. Okay, I got to think about this more carefully. Left, right equals query. Left, right in cache. Right. Okay. If prev left less than left, I'm going to do prev left equals left and cache dot clear. Ooh, no. Better yet. Okay. Whenever we update prev left, oh, but if we XOR element, oh, okay. Is it really worth looping over all of cache? Probably is, right? Okay. Parent cache. L comma R equals pair. Prev left. Prev left for I in range prev left plus 1 and include left, so left plus 1. XOR equals XOR. Actually, you can probably do something like this in Python, right? XOR equal. So if I do something like Python 3, A is equal to 2, A XOR equal 4, A. Okay, there we go, cool. XOR equal. You know what? Let's do that here. With R of I. For key and cache of key XOR. Prev left was left. Okay, now that's where the trick part is. Okay, so essentially the part is like, if you have something like 0, 4, right? And you've computed the, okay, this is kind of gonna be a little bit genius. In fact, cache is no longer gonna store pairs. We're only gonna store the right variable. We don't need to do cache.clear. Let's keep this like here. If right is in cache, do this. Cache of I is going to be equal to XOR. D of left comma right is equal to XOR. Okay, cool. Okay, first of all, let's run something like this, but what's going on? Okay. Okay, but let's think about this. Left comma right equals query. Okay. Mm. Left, right. Do I want to execute this though? Left doesn't equal -1 and this. Let's put that after just for short circuiting purposes. But okay, XOR equals this for I in range. So get the XOR of the values. For key and cache, do this, and then prev left is equal to left. Cool. Then if right is in cache, then yeah. Wait. Yeah. Yeah, this doesn't make sense. Not anymore. Print cache, print D, return empty. What's going on here? 0103. And how many are there? Missing 1 and 2 for some reason. We're literally doing this for every query. Okay. This should work. I'm missing exactly one case for all of them. I'm missing 1 and 2. I'm missing 1 and 2 and 3 and 3. Why? Print XOR. Why am I only doing 2 iterations? Left comma right. Cache of right. This is important. Okay. We just have to have the results. Okay. Yeah, now we have the results in there. Okay. Two, 6, 14. Interesting. Okay. So yeah, so 0, 1, and 0 and 3 are going to be correct. Then 1 and 2. 1 and 2 should be computed on its own. So that one doesn't make sense. I do those ranges correctly. Maybe I shouldn't there. No, that's not the problem. Gotta think. 3 and 3. Right, so the idea is that, first of all, okay, so that's not what I wanted on. Or maybe we pre-compute the XOR of 0 with everything. That would be a great idea. Let's just do that. Pre-compute XOR of zero comma I for every index I in R. Okay. XOR is equal to R is at least length 1, right? Yeah. R of 0 for I in range length 1 all the way up to the length of R. Remove a parenthesis here. We're going to say XOR equal R of I. Zero to itself doesn't really make much sense, right? It's just itself. Cache of 0 comma I equals XOR. And in here, assert false here. Dang, so I reached this case. That doesn't make sense to me. Oh no, I don't want tuples. I want this. Really? Print write and print cache. Oh my goodness, okay. Okay, cache equals R of 0. Cache of I equals cache of I minus 1 XORed with R of I. There we go. What? Set object is not subscriptable. What am I doing here? 0. Okay, I don't assert false there anymore, which is great. Okay, now we gotta figure out why on earth this does not work. Okay, because I'm pretty sure this idea will work. My idea right now is essentially this. All I'm trying to do is essentially I want to have 0, 0. I want to have that, I want to have the XOR of all the indices between 0 and 0, which is just the first element, 0 and 1, 0 and 2, etc., etc., all the way up to 0 and n minus 1, where n is equal to length of r, right? And my idea is that if I sort the queries, I'll first have the 0 elements all together at the very beginning, or whatever is the smallest one, right? Actually. Okay. Min index. Actually, prev left, I can keep it at 0 here. And then, okay, let's do this. Okay, getting closer. Okay, right, because now if it wasn't 0, I essentially have this being a new index. Okay, I probably don't want to include left here, right? Oh, okay, there we go. Okay, let's submit this. Dang, is it really still slow? I have n things in the cache now. I time limit exceed, it's that slow. Really? What? Right, so if I don't need it, oh my goodness, this is so frustrating. Okay. I thought I had a clever idea, which is if I go back to this, the idea is that like, if I get something like 2, 4, right? The idea is that I XOR everything with elements at 0 and 1. That way, essentially, my cache will now be 2, 0, 2, 1, 2, 2, etc. Okay, first of all, that's also one thing I can do. Like 2, 0 doesn't make sense, right? So, oh yeah, okay, that'll. For keying, if yeah, it's only right elements now. Min right equals 1. Okay, it's already an improvement at least. Just I can't believe I time limit exceed. Okay, I might just take the L on this problem then. Well, I mean, okay, obviously we have a solution to the problem, but it's 5% is what it beats. It's just not fun. It's like there's got to be some sweeping idea. Okay, you know what? I mean, we came up with a solution already that works, and it does pass 5%. But I want to make sure we solve this efficiently. So you know what? This is a good time to look at a hint, in my opinion. So let's just do that. All right, what is the result of x, y? Yeah, okay, this is just y. Compute the prefix sum for XOR. What's the prefix sum again? Process the queries with the prefix sum values. Are you saying that maybe I should keep Ooh, that just gave me an idea. Maybe I keep, so maybe this is good. Maybe this is good, where I have 0 to I for every I in R. And then I still use my prev left idea, but I XOR all the way up to left of prev left. And any value from then on, I can consult my cache. Okay. Interesting. I think I like this idea. But it does require sorting queries, right? Okay, cache equals 0, R of 0. So, okay, I like this idea. I like my prev left idea too. I wish, okay, so just in case, let's save our solution from before down here. All right, well, otherwise we don't need this for now. Okay. Okay, so now we are free to go rampage on this guy. So we have our cache with 0 to I for every I. Then left, comma right is go to query. If prev left is less than left, then okay, we're gonna call our XOR. Okay, our XOR is going to be equal to essentially R of the minimum index, 0, prev left. Essentially what I want is if I have an index 1, right? Because the queries are sorted, I XOR all the way up to that 1. And then for every one I see, I will XOR with this value and so on, and append to the dictionary those kinds of results. So I think that's actually very clever. Ooh, that's actually so clever. Okay, it's essentially the idea I had in mind. It's just actually well executed. Okay, that's actually kind of exciting. Okay. The hints were good. The hints were very good and so on. I don't even think, this might not even be what it meant, but it made me think of what I wanted to do. So okay, so this is good. XOR equals R of 0. I have an oh, whoa, my hair. whoops. Okay, XOR equals R of 0. Poop. Yep, for query and sorted query. So the sorting is very important for the idea I want to implement. Left and right equals query. So yeah, this will trigger on the very first one. If I do range 0, 0, colon 0. Right. Because yeah, no matter what I choose to XOR something with, I get screwed. Oops. Okay. First of all, we're just gonna say this, right? If left is equal to 0, d of left comma right is equal to cache of right. That's our base case, right? That way it's like when we can update our prev left and left as we want them to, right? So prev left is going to be equal to 0. Okay. Right, this can be some dummy value for now. Otherwise, we'll have XOR equals array prev left. We'll have everything as we want it here. We don't include left because that's what we're going to start from then on afterwards, so that makes sense. For now, I don't need something like this. Actually, I want to make sure I don't delete that. XOR equals array prev left. In fact, I'm not going to do something like this anymore. I'm not going to loop through the keys of cache. But I am going to update XOR properly. That is very important. And then prev left does equal left. So everything is updated. And now, I essentially just say d of left comma right is equal to cache of right left comma right equals XOR with cache of right with XOR. Yeah. And from here continue. So let's run something like this. Also, I can put myself back here. So we have a wrong. Oh my goodness. Okay. Okay. So we've got some debugging to do. Okay. Okay. So we've got every index in there. Just why the heck am I getting negative values? That makes no sense. Am I XORing stuff properly? R of I? Okay, XOR is initially -1. This is what's going on. Oh, and continue. Oh my goodness. Okay. Wow. Okay, we're off by 1 here. And so that's the 3-3 example. So if left equals right, d of left comma right equals, so this is base case number 1. Base case number 2. And we're just going to say this is R of left. Bruh, okay. I always forget this. Oh my goodness. Okay. Oh, what's wrong with this guy? Print sorted queries. And then print queries. Actually, I have them here. So 2, 3 is what's failing. I might as well set this to arg0 at the beginning. Okay, that's a bug actually. Okay. This makes sense. I don't want to reset XOR to the. Basically, a good way to do it would be literally this. First of all, I think this would work. What? What am I? Bruh. That cannot be wrong. Plus what or something? Oh. Yeah, this should be arg0. Okay. And then for 1 to left. Okay. Essentially, that's what it should be. Yeah, okay. So that's what it means. So it's like you got to restart from the very beginning. But essentially, you already have XOR is currently value from 0 to prev left. Not inclusive. So essentially, I don't need to reset XOR. I say for I in range prev left to left. This. It might be plus or minus 1 here or whatever. Right. So I might just need to do some plus 1 stuff here. And making sure. Maybe this. There we go. Okay. Okay, so first of all, let's submit something like this and see if it works. Okay, but okay. We're still at 5%, but the world of difference is unbelievable. We were at like 6,000 something milliseconds. Now we're in the 377 ranges, right? And okay, like we're only like up to 70 milliseconds slower than everyone else. So it's like world of difference when it comes to the speed of this problem. Okay, so that's cool. So we can definitely scrap whatever solution was in here. Okay. 377 is definitely better than 6,800 or whatever it was before. Okay. Okay, so we made great progress. Results. Res type of query. Okay, so we can get rid of this stuff. Oh, we're also printing, aren't we? We can also, if we get rid of the prints and we resubmit, do we become faster? I guess we were just printing two stuff at the end, so it's not that bad. Okay, so let's make sure we get rid of the D's here. Res. Do I even need to do something like this? Nope. This one is important though. Okay, we're at 350 though. So it's like we're definitely way closer at the very, very least. We're not in the 6,000s ranges. So even though we're like, we're still at the 5% range, I'm much happier about this because before we were, our solution was like 6,800 instead of 350. And these guys are like 300 something and so on. So I think the extra 50 milliseconds is probably for sorting queries. I saw in the hints that they don't sort queries. So maybe they do some prefix sum stuff that they're able to get. Oh, you know what they might be doing? They might literally be doing something like this, where it's like, you know what? I think I know exactly what they're doing. Where they're doing, let's see if this is faster. So let's bring this down. It might be faster in the sense that it's worth not sorting queries if you can do this. So let's put this here. Res equals an array. That append cache of write. We're not going to do this. One comma left. So they might literally be doing something like this. Res.append this. So it's like they recompute the XOR every single time instead of having it sorted and so on. And then here, return res. So what if they do something like this? So this works, and let's see. If it's faster, it's faster. Oh, it might actually be too slow. Oh, never mind. It's too slow. But they might do some... Actually, I know. I have another idea. Okay. Whoops. Okay, I definitely want to make sure that's in there. Okay. XOR range. XOR range is equal to 0, 0 at the moment, and we can always update this range, right? And then it's like we can always conform the range to whatever we need it to be. But yeah, at that point there's just like minute implementation details and so on. All this just to like avoid not sorting queries and so on. So I'm guessing that they like you're able to just like barely do extra work, and you don't actually need to sort queries. Where it's like, okay, if your left like changes, like just recompute a little bit, or like keep track of things you've already computed and so on. So it's just like a little bit of optimizations. But at this point it's like even though we're that quote unquote like only 5% better than most solutions, or 6%, it's like we're at 330 milliseconds, and like these solutions are like 307, 310 and so on. So so like the median is around 300. We're like barely 30 milliseconds slower and so on. So even though we only beat 6%, it's like we're barely worse, but it's at least much better than the 6,000 millisecond solution that we had earlier, which that one definitely for sure should be failing. But yeah, otherwise, let's make sure that we get rid of a bunch of these comments. So, res equals that, perf left equals 0, XOR equals that. Okay, this case. Yep. Not inclusive. And yeah, so it's important that we initialize it to 0. Case prep left is still 0. In fact, we could set this to 1. Right? And that way we just have prep left here. Because we already handled that if equals 0 case. In fact, if I run this, this should be okay. And if I submit this, that should still be okay. Very nice. Okay, for cache key, let's get rid of this. There's it left. Okay. Return back query results in original order. Queries order. Okay. Oh, our solution is only 28 lines now. We went from like hundreds to like just 28 lines. Okay, so we can just submit this one more time, and there we go. Even though we only beat like say like okay 9% of the solution, like look at this, like the medium right here, like the 50% whatever range and so on. It's right down at like this 308 milliseconds. We're at 323 and so on. So I think we're a little bit slower because we have a solution that requires sorting queries at the very beginning, whereas like from the hints it seems suggestive that there might be a way to do this problem without sorting queries. But otherwise like we're barely slower, and from then it's like it still allows me to do some stuff like very efficiently, where it's like maybe over like really large like over extremely bad queries inputs, it's like it might actually pay off well and so on. Doesn't matter too much, but yeah. So that's pretty much it for today's video. As always, I always do a quick summary of how I was able to solve the problem for every single one of these LeetCode videos. So essentially for this case, like the problem is very straightforward, in that you're given an array of positive integers, also given the array queries, where queries I represents 2 indices left and right of the array integers. And essentially for every query from index left to index right, you essentially want to take the XOR of all the values in an array from left to right. And so what I did is the very first thing is I sorted queries. That way it's like I get all the left and right pairs that start with index 0, then followed by all the ones that like start with 1, and then the ones that start with 2, or maybe there's gaps if there are no ones that start with 0, or there are no ones that start with 1, and so on. The point is that like instead of having queries like this, I'll have like 0, 1 at the beginning, and then 0, 3, and only then do I have 1 and 2, and only then do I have 3 and 3. So it's like by at least the very first value are they sorted, and even then by the very first value and the second value. And so when you understand that, essentially all I have is I have the pre-computed values of the XOR of all elements from index 0 to index I for every I in an array, right? So it's like for any index I in an array, I pre-compute the value of XORing every element from index 0 to that index I, right? And so the way I do this is I set, I know at index 0, the XOR of yourself is just yourself. So it's like, sorry, well, that's not true, but like yourself before any XORs is just yourself. So at index 0, it's just the original element, and then from every element after that, I essentially XOR the previous result with the current number in R. So like R XOR the previous cache resource, starting from the base of the first number for index 0, and that's essentially how I get the XOR of every index from 0 to I for every index I in R. So that kind of makes sense. And the reason why I do this is one property about XOR is that if you have anything, right? So if you have some text and you XOR it with, let's say, some secret key. Well, the way this works is that if you XOR this again with secret key, what you'll end up with is just test. So essentially, when you XOR the same thing together, A XOR A is equal to 0. So it essentially disappears. And so they're a very useful property. In that, if I XORed, say, the numbers from indices 0 to 4, and I XOR this with the value at index 4, essentially what that gives me is just the values from 0 to 3, right? Because this 4 will cancel out with the 4 from over here. Or similarly, if I did the element at index 0, it would cancel with the element here at index 0 and will give me 1 to 3. Sorry, I just swallowed something weird in my throat. I don't know what's going on. Sorry. Okay. I hope I'll be able to speak. That's weird. Sorry. Okay. Test secret key. So if you XOR something with, if you take something, XOR it with a value, and you XOR it with the same value again, even if it's not in the same order, it will essentially disappear, right? So that's just a property of XOR. And the reason I know that is, again, because I took a cybersecurity class in college and so on. And so we always work with we work with cryptography a lot, and obviously like the easiest cryptographic algorithm like ever, besides like Caesar cipher, is like XORing stuff. And the reason is like because there's like these nice properties and so on. So it's like the way you encrypt is the same way as you decrypt, right? Where it's like if you have a key, like if you have some plain text, your encryption algorithm is essentially XORing it with a secret key, and your decrypt algorithm is taking that ciphertext and ciphertext is equal to this, and then it's like plain text. The way you get your plain text back is you take your ciphertext and you XOR it again with key. And the reason why is because like if I do ciphertext XOR with key, so this is essentially the same as plain text XORed with key, which is equal to plain text XORed with key XOR key, which is equal to plain text XOR with essentially 0. And we know that if you XOR with 0, essentially it's like if you have 0, it becomes 1, and if you have 1, it becomes 0, or so I swear it's like it doesn't give you the reverse input. It gives you the XOR gives you 0 if they're the same element and 1 if they're different, right? So it's like if you have a 0 because they're the same, you'll stay at 0. If you have a 1 because they are different, it'll become a 1. So this becomes plain text. So that's kind of why. That's kind of like a mathematical explanation why, where it's like if you XOR something with the same thing that you XORed with before, you essentially get the original result. And so that's just something I learned in my security class. And okay, so knowing that, essentially, now that I have all these pre-computed values of the XORs from every element in R, 0 up to that index, well, this is where things get juicy, right? Where essentially it's like, because the very first thing is I sort all my queries. And the reason I do this is because, again, my left value will be at like 0 for all the first or so queries and so on, and then they'll all be from 1 and so on. But the way this works is like, first of all, if I get a query where the left index is 0, I've already pre-computed all the ones from 0 to I for any index in R, right? So I return that result directly, right? So if left is equal to 0, I already have that value pre-computed and just go on, right? Otherwise, I keep track of my previous most left. And the way this works is like, essentially it's like if zeros we can ignore for now because we have the case covered, but it's like my previous left is equal to 1 here, right? And so I might end up like tackling all the ones with 1, 1, 1, 1, 1, 1, but then at some point I might get to this 3, right? And so maybe an easier case is because let's say since we have all the zeros, we're gonna say like, okay, let's say I want the 1 and 2, right? The way this works is that 1 and 2, what you have to recognize is that, okay, let's take all the numbers between 0 and the very first number in here, which is 1. So let's take the XOR of everything from like 0 to index 1 and XOR this with everything from 0 to 2. Well then, essentially, it's like, I'm essentially, if I take the first element and then I XOR I take that element and I XOR it with one. Okay, I'm not doing a great example here, but it's like the elements from 1 and 2. If I XOR this with the element at 0, right, r of 0, then I essentially get r one all the way up to 2. Does that make sense? So it's like if I have, let's say this is n minus 1. Okay. If this makes sense, this is good. Essentially, if you have the XOR of all these elements, right, from 0 to n minus 1 in R, and you XOR it with, okay, r of 0, let's just do r of n minus 1. There we go. If you essentially have the XOR of all these values together and you XOR it with r of 0, you essentially cancel out the r of 0 from here, right? So you're only left with the XOR of the arrays for elements 1 to n minus 1. But even better than this is, let's say, if I XOR it with all the values from r of 0 all the way up to, say, r of I, where I is between 0 and n minus 1, then essentially this gives me, if I do I minus 1 here, everything from I up to n minus 1, right? So if I essentially I pre-computed the XOR for every value from 0 to n minus 1, right? So from 0 to j, for any j between 0 and n, that value is already being pre-computed in terms of the XOR of all those elements together, right? So this part here on the left is something that we have, right? This thing on the right is what we want, right? So like we always are given some two pairs of integers, left and right? For right, it doesn't really matter, right? Because we've essentially pre-computed the XOR for every index 0 to I for every I in R, right? So essentially we have one element for every possible index right that right could be an array, right? But then what we're going to say is like, okay, we obviously want this, the result from left to right, whatever left is. And left might not necessarily be 0, but that's okay. Because what I'm going to do is I'm going to go all the way up to left minus 1 and take the XOR of all the values from 0 to left minus 1, inclusive, right? And what's this going to do is if I XOR that result with everything from 0 to n minus 1, and I XOR it with everything from 0 to left minus 1, I essentially cancel out everything between r of 0 and left minus 1. And all I'm left with is left all the way up to n minus 1, right? Or here I can call this right. Right? Essentially, if I want to go from r0 to r of right at any point, this I have. Doesn't matter the index of right. I want this. I want from left to right, right? For every query, I want the XOR of all the values from r of left all the way up to r of right. That is what I want, right? So this is the desired thing I want. But essentially, I say, I already have this value pre-computed. I just need to get this value. So I just need to compute the XOR from everything from index 0 all the way up to index left minus 1, right? And so the reason why I sort all the queries at the beginning is essentially, let's say I could pre-compute everything from r of 0 to r of I, where I less than left, right? Then, okay, then at this point, if I want this, I can always do this, right? Where it's like, okay, if I is equal to left minus 1 at any point, then great, we already have the thing awesome sauce, doesn't matter and so on, right? This is why in my code I have a check like if prev left is less than left, only do something, otherwise you're already done, right? So the previous left. So essentially, I'm going with these guys in order. Everything starts out as a 0 at the beginning. The very first thing I change in this case is like with the 1, right? And so from then on, essentially what I can say is like, okay, if my I is equal to left minus 1, I've already done everything. Otherwise, if it's less than that, essentially XOR all I want is from R of 0 all the way up to R of left minus 1. This is essentially equal to XOR R of 0 all the way up to dot 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 R of I XOR with XOR from of I plus 1 dot 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 all the way up to R of left minus 1, right? If I'm XORing all the elements all the way up to I, and then from I plus 1 all the way up to the left minus 1, I essentially have the XOR of all the elements from 0 to left minus 1, right? So essentially this allows me to keep growing my XOR, where it's like at the beginning I just have 0, but it's like as my left value here gets bigger and bigger, because again I sorted the query so they're all in increasing order. As it gets bigger and bigger and bigger, right, this left minus 1, this left value, because my queries are sorted, then I'm just going to keep growing this value, right? Where it's like my I is always going to be less than or equal to the left, right? And so if I do this, maybe this is an easier explanation. I minus 1. There we go. So essentially at any point, I have this. If I is equal to left, then great, I already have the thing, right? Because I minus 1 and left minus 1, they're the same thing. If they're not, then I XOR it with everything in here, right? From I all the way up to the left minus 1 and GG. And because my queries are sorted, I have the claim that I is less than or equal to left, so I can do things this way. Otherwise, I'd have to like find discrepancies and go left and right and so on, which I'm sure is possible and so on, because other people have different solutions that tend to be a little bit more efficient, I suppose, and that way you don't have to like, you know, sort queries, which is like a very expensive computation. But yeah, that's essentially it. So I hope I'm making sense here. Was like essentially the thing you have to realize is that if you want the XOR of all the elements from left to right, this is essentially the same as all the elements from 0 to right, and then XORing that with everything all the way up to 0 to left, not including left, right? Because again, this cancels out all the way up to left minus 1 elements, because again, like that example that we were talking about with the plain text and ciphertext and so on. And then once you have that, it's game over, right? Essentially, this is something you've pre-computed, so you always have it. This is the thing that you want, and this is just something that you have to make sure you compute efficiently. The way I did it is I sorted queries. That way it's like I always have this nice, neat I is less than or equal to left property that I can always make use of, and bada bing, bada boom, just always computed super efficiently, where it's like it only grows as needed. And although where the worst case is that I end up XORing all the elements in the array, which is like, that's the worst case of the total computation of the XOR that I'll have to do. It's very, very, very efficient. The part that's very inefficient is the fact that I have to sort all of queries, which is like, you know, a big bummer. So it's like, there's probably a way to, you know, like just do it a little more efficiently than having to sort queries. But that was my solution. So this is very good. I might even take something like this and put that comment somewhere just so that it's on my GitHub. Oh my, that cup car is a little loud. But yeah, maybe I put this here. It's okay. At least I have it in video. That's what matters. So okay, I can just get rid of this. But there we go. All right, that's essentially it. So we can just submit one last time, and there we go. 6.93 again. We're 330 milliseconds. We're only like 30 milliseconds slower than these guys. I think it's because again we're sorting queries. It's like our XOR step is going to be way faster this step than whatever they can possibly do. But again, the fact that we have to sort queries is pretty inefficient, so it might bring us a little bit slower and so on. But I couldn't figure out a way yet, or at least not thinking too much about something efficient without sorting queries. But I'm sure there's some clever way to do it. So But otherwise, that's pretty much it. I hope that that solution kind of made sense and so on, and that you were able to follow along. In case you want to do something similar to what I do, by the way, the extension that I use is called LeetSync. I trust this extension, but by no means does this mean you have to trust this extension yourself. Essentially, what these guys do is whenever you submit your problem here on LeetCode, they'll automatically submit a copy of your solution onto your GitHub repository. So if I come in here and I search up XOR queries of a subarray, you'll see that I committed something just now, even though I was not on GitHub just now. And every time, so the very first time that you submit the problem, it'll upload a copy of the README to the problem from LeetCode. And every single time you resubmit a correct solution, it'll post your code that you just used for resubmission and be right there on display available just for you to see. So very, very useful extension in case you want to do something similar to what I do. But again, always do your own due diligence before you trust a random guy like me on the internet. So just always plugging that out there. But otherwise, it's pretty much it for today's video. If you did find it enjoyable, I would highly appreciate if you left a like or a comment. As I say on my videos, if you leave a comment, I promise to respond to every single one of you, and it doesn't even have to be technically related to LeetCode. So whether you want to talk about LeetCode or anything else, even if it's your hobbies and so on and not technically related, please feel more than free, and I would love to have a chat with every single one of you guys. But otherwise, that's pretty much it for today's video, and I'll just catch you in the next one. So until then, ciao ciao, my friend. Bye bye. Okay, hey there, sorry, this is the only time I've ever done this. I've never recorded an extra section after I finished the video, but I was curious, and I went through the editorial solution because I wanted to see how everyone else was able to do things efficiently. I have no idea how I didn't just think of this. What these guys do is if I come back here, if I can control Z maybe, yeah. Here, when I was talking about XOR array from 0 to right and so on, and I'm XORing everything from 0 to left, I already have everything pre-computed from 0 to any index I. So if I want something from 0 to left and so on, I already have access to it. I don't need to keep track of an XOR variable that I'm computing stuff and so on and da da da. So yeah, that's a very, very easy fix. So I can look away from the editorial, but essentially it's we can make use of the fact that we already have oops, so that's okay, that's for my recording of the initial video. But okay, just speeding this up a little quickly. I just figured I'll show this because this is a little curious. I've no idea how I missed this, but essentially I was doing a lot of effort to compute the XOR value from 0 to left, but I already have all the values from 0 to I pre-computed for me, so I can just make use of that whenever I want 0 to anything, because that's specifically what I want, right? And so here, this XOR value, I can just say, hey, XOR is equal to cache all the way up to index left, not inclusive, right? So maybe left minus 1. Okay. So let's, oh yeah, this stuff. Okay. If I set this, let's see if this works. Okay, so that works, which means I can get rid of all this over here. I can get rid of this and this. Oh my goodness. I can definitely get rid of the sorted queries. I can definitely, okay, I can keep res, but as an array, so I can do this as queries. We're gonna instead do res.append here. So essentially, what we want to say is that this is logically equivalent to that, which is logically equivalent to cache of right XOR cache of left minus 1. That's so I don't know how I missed that. Okay. That's my fault, but just because the change is so simple, I figured I'll just record a little bit of the video extra onwards and so on. Maybe I should start doing this where it's like at the end of my videos I make reference of the editorial solution and so on to see like what I missed, because I totally didn't think of doing that before. Like I only look at the editorial whenever like I couldn't solve a problem, instead of like when I solve a problem and so on, looking at it in case I miss things. And like this time I'm like very glad I did, because it's like that is something like I was like, how did I miss that, you know? And so it's like it helps me build better habits and so that's very good. And that way we at least get to include this little comment that I was talking about that I wanted to keep. Yeah, so now we just have things like this. Otherwise we do, actually we can probably get rid of this, right? So if I run here, okay, well this is not going to work, but for a different reason. res.append cache of write. And now if I do this, oh yeah, res, I can get rid of this. Okay. Oh my goodness, that's so sad. Okay, if I get rid of this, I don't even have to hard code the 0 case, do I? Oh, actually, yeah, because I do. Res.append. Of left -1, left 0, of right. Okay, I can just leave it as an if. I think that's actually cleaner in terms of code readability. There we go. Okay, so we can run something like this. Okay, but something like this is definitely much better. Okay, and we're already at 20%, and if we resubmit a couple times, you know, maybe we change this to be an else over here. Okay, for some reason my computer's being slow right now. Actually, I like it as a continue, but yeah, so essentially, yeah, if we resubmit this, we might get more closer to this rate and so on. And there we go. Or 28% and so on. Maybe it's because they use an array instead of a hash map and so on, but yeah, like this is definitely much more efficient and so on, strictly because we no longer have to sort queries, right? Which is very good, right? I don't know why I didn't think of this and so on, but again, just because it was so simple and like so elegant, I really wish I figured that out, because like this is just like super elegant, whereas like this actually had a dual purpose instead of like a singular purpose, because I was just so tunnel vision on my idea that I didn't even realize that I could use stuff like that. So yeah, just very excellent, elegant solution and so on. So sorry to kind of make the video run over a little more and so on. It's just I figured that I showed that because I just looked at the tutorial and I was like, no way did I not just realize that and so on. So I figured I'd show you, and I hope that makes sense. It's just the very same argument. It's just that instead of computing this part in the way that I was explaining earlier, you can take note of the fact that you already have everything from index 0 to any index I, including left -1, so you can just compute the value here as such. So that's essentially it, and that's it. But otherwise, yeah, that is it for today's video. So in case you enjoyed, I would highly appreciate if you left a like or a comment, but otherwise I will catch you in the next one. So now for real, I'll catch you in the next one. Ciao, my friend. Until then, bye-bye.